Reliability Solutions presents Key Tips, Techniques, Behaviors, Methodologies. Welcome to Chalk Talk.
Hello and welcome to Reliable Manufacturing Chalk Talk. My name is Tim Dunton with Reliability Solutions. This episode is about achieving precision balance results in the field.
As with most tasks, preparation is the key to successful field balancing. Make sure you have the correct tools for the job. This includes an accurate digital scale, ideally with both grams and ounce scales, trial weights or clips. This is an example of a kit that our service guys use, and these kits are readily available from various different sources. An angle finder is a must. Nowadays, many of the smartphones have good clinometer applications which can be used here, provided we can find a way to attach it to the shaft. Of course, we also need a data collector and a photocell, and then a selection of wrenches, tape measure, and various hand tools and metal markers to mark weight positions. A flashlight and a strobe light are also good tools to have along as well. You're going to need certain information to be able to determine if you have reached a precision balance standard. At a minimum, the information needed is the weight of the rotor, the service speed, and the radius at which you are adding and removing weights. It's also useful to know the position of the center of gravity relative to the location of the bearings. We always recommend balancing to a precision standard such as the API standard or an ISO G1, which are both very similar to each other. Personally, I like to use the API system because the calculations are simple. The maximum unbalance per plane, U sub per, should be 4 multiplied by the static journal load in pounds, which is 50% of the rotor weight for symmetrical rotors, divided by the service speed, 4W over N. This will give you an answer in ounce inches. Once we have this information in hand, we're now ready to start balancing. The balancing procedure is basically the same for all of the different instruments. We do an original run, noting the amplitude and phase in both planes. We then apply a trial weight to the left-hand plane and redo the run. We then remove that weight and apply it to the right-hand plane and then redo the run. And then at the end of that, the instrument will give us corrections in both planes. After applying the correction weights, we will then do another run and validate the readings and see if we need to trim. The data collectors really step you through this process. All we have to do is follow the instructions. When selecting how much trial weight to apply, we're looking to see a 30-degree phase shift or a 30% change in vibration amplitude as a result of the trial weight. Most modern balancing programs have trial weight calculators built into them, and while the numbers produced tend to be a little conservative, we strongly recommend they are used until the technicians get a little more experience under their belt. We should keep balancing until such times as the trim correction weight suggested by the instrument, when multiplied by the radius at which we are applying that weight, does not exceed the tolerance value previously calculated. At that point, the rotor has achieved the appropriate balance standard.
Well, there you have it. Achieving precision balance results in the field. With these modern data collectors, it's actually pretty easy to get great results.
Reliable manufacturing is effective organizations, precision maintenance, process excellence, and asset condition assessment. get your reliable manufacturing roadmap, contact us now